Hello, I'm Philip Stoten. I'm here at Apex 2019 and I'm on the SCOOPstudio. I'm joined by MB from KIC and Kim from Indium. You guys have been running this Void Clinic, which I think is really interesting. MB, start by telling me what the objective of having the clinic is here, and then we'll go on to some of the challenges that have come up.
Sure. We've done collaboration with Indium in the past. Voiding is a continuing problem. It was years ago specific to BGAs. We see it now all the time. And Indium has some wonderful solutions, and together with profiling and different solder materials, we feel that we can help some customers. And our goal was to try to get customers to tell us more and more about their problems so that we know the direction that we need to take in the future as well.
Okay, and Kim, they came with their various different problems. Tell me a bit about some of the problems you saw, and were there any from, I'll give you this mic, or I'll hold it here. Tell me if there are any that kind of came from left field that you weren't expecting.
So the people that came to visit us, a lot of the problems that they had were primarily for bottom termination components, QFNs and LGAs specifically, and they tried a little bit of everything. They tried window painting the apertures, they tried increasing the stencil height, they tried multiple different profiles, higher peak temperatures, lower peak temperatures, but we worked with them and we gave them a few other ideas to try out, and they think that they may be able to come up with a solution.
Okay, and what kind of ideas were you offering them?
So some of the things that we had suggested to them were higher peak temperature, and then the cool down rate, focus a little bit more on the cool down rate of the profile. So a lot of times you'll notice that an SN63 solder joint has much less voiding than a SAC 305 solder joint does. And primarily that's due to the plastic range that exists in a SAC 305 alloy. So you have a solidus and a liquidus that are not equal. So in between that 217 degrees Celsius and that 220 degrees Celsius, you have kind of a sludgy state that the solder is in. It's not really a liquid, it's not really a solid. So you've got the flux that's trying to outgas and push through underneath the component. It just makes it that much more difficult, and it gets caught up in that sludge and creates multiple voids. So by increasing the cool down rate and reducing the amount of time that the temperature of the solder is passing through the liquidus to the solidus, that will, in increasing the rate of solidification, that will decrease the amount of voiding.
Okay. And MB, when you look at this, obviously voiding's an issue, but when you look at it specifically, is there a requirement to identify what's an acceptable level of voiding? I mean, do some people come worrying about voiding and it's actually not necessarily the end of the world because of the measurement or the test that you do?
That's an excellent question, because we do get asked that question often. We have seen that so many companies have been told by their customers, we want to see less than 5% voiding, we want to see less than 3%, and I think yesterday Chris Nash mentioned he had a customer say less than 2.5%. There really is no standard for voiding or an acceptable amount of voiding or percentage, with the exception of BGAs. IPC does have a standard for that, but as far as the BTCs, the QFNs, etc., there really isn't. And part of that answer really depends on what type of voiding are you having. One of the companies we spoke to, they were having a combination of large voids as well as multiple voids, and they were scattered throughout their different components. So that's where you really need to look at the profile and try to adjust the temperatures, because you have a double problem that you're trying to resolve. We try to look at different ways to not just optimize the profile, but be component specific. So if I have this problem, I may need a different profile, and I have to find a good profile to address all of those issues. So that's where we really look at the profile as a big factor in solving the problem.
And Kim, you can't improve what you're not measuring. So if someone comes to you and they're saying, I've got a voiding problem, but they haven't got a real idea of what their profile is, I guess the first port of call is to get that profile recorded.
Right, so oftentimes customers don't have profilers, so my job is to go in and we have a profiler that I can bring in and on-site, do some profiling for them. And a lot of times they'll be surprised. Sometimes their profile, their oven settings that they feel are within spec, they actually aren't in spec, because all the components add different types of thermal masses, and they are surprised at some of the differences that different components can measure as far as temperature-wise for the reflow profile.
Yeah, and that gives you that importance of actually measuring a process, not just measuring what the machine says.
Exactly.
And that makes all the difference. Is profile kind of the first port of call before you start to panic and throw out machines and throw out consumables?
That's my first line of defense.
Yeah.
Profiling is my first line of defense. It's the most cost efficient. It's the most immediate solution.
Is it the most common solution? Is it the most common?
I think it's the most
success?
common solution, just for those reasons, that it's most effective, most cost effective, and it's a quick solution. So there are, of course, other methods of reducing voiding, such as stencil design and printing parameters and such, and solder paste. Different solder paste flux vehicles will void differently. But as far as coming up with an immediate solution, reflow profiling is my first line of defense.
Yeah, get to the profile first. MB, the relationship you've had with Indium has been fruitful for a long time. Tell me a bit about that partnership and how it kind of continues to develop and help you and your customers.
Well, I think a lot of it has to do with so much work that Indium has done, especially in voiding. I mean, you can go on the internet and you could just find so many different papers and variables for all different types of voidings and different solutions. We've been fortunate to be partners with them. They've used our profilers for a very long time in their labs and now also in the field. Kim, as an applications engineer, has used our profiler to help customers. And, customers ask us for solutions. We have someone to refer them to, an expert in the field, and there's a bunch of them at Indium which are wonderful, and they're very, very nice to work with. We love them.
I think what I've always found impressive about Indium is, you have this whole avoid the void strategy, but that's supported by this engineer-to-engineer communication that you do so well, and that breadth of engineers that can talk the same language and can help directly with someone's problem. That's a really important part of how you promote your business.
Absolutely. I was actually just telling MB today, it's very beneficial to an engineer to see the data. You can tell people all that you want, but to an engineer, that what you're saying isn't going to be anything to them unless you actually give them data or give them proof that this is what's happened. So I think that's where the benefit of having tech support and engineers in the working in the lab and working with the materials and working with industry partners and profilers and knowing what our customers are doing and having that connection to be able to communicate with them better.
Yeah, always wonderful to see such a successful collaboration, especially when it's helping customers. Thanks for stopping by, thanks for chatting, and enjoy the rest of the show.
Phil.